Here's your video for solving systems of linear equations, solving by substitution. Here's our first example. We have these two linear equations. Each one is an equation in two variables. When we're talking about a system of equations, we're talking about these two equations working together. And the solution to the system is actually going to be the solution that works for both of these equations. We often see the two equations when they're together in a system written with this brace or curly bracket on the side. So we know that when we're looking for a solution to the system, we're looking for the solution that works for both equations. Now, a reminder, when we're talking about solutions, we're talking about these xy ordered pair solutions. A solution for an equation that has two different variables needs to have two different numbers in the solution. A solution for x and a solution for y. And remember that these are ordered pair solutions that make the equation true, and we have an unlimited number of them. I got started here with a first solution. What happens, and just think about our top equation. If x equals 0, we would have 2 times 0. So what does y have to equal to make this equation true? 2 times 0 would be 0, and 0 plus 9 equals 9. So if 0 is the x coordinate of the solution, 9 would be the y coordinate, or the y value. So there's an ordered pair solution to this first equation. But remember, there is this unlimited supply. What if we thought about a different ordered pair solution where the x value was 1? In the equation, 2 times 1 equals 2, so 2 plus what number equals 9? In this case, y would have to be 7 in order to make the equation true. And we could keep going and finding more and more of these ordered pair solutions. But the key is it has to be an ordered pair solution that works for both equations. We know these two work for the top equation, but let's take 0, 9. Would that be a solution to the bottom equation? Well, if x equals 0, 3 times 0 is 0. 0 minus 1 will not equal 9. So definitely we do not have an ordered pair solution for the system, something that works for both equations. And 1, 7 won't work either. If x equals 1, 3 times 1 is 3. Minus 1 equals 2, not 7. So another ordered pair solution that works for one of these equations, but not both. Now, rather than going through a long list of solutions that work for one equation, and then one by one checking to see if they work for the other equation, thankfully we do have a series of steps we can follow to get to the exact ordered pair solution that works for both equations. There are a couple of important mathematical ideas at work with this process of substitution that we're about to learn that I want to go through first. If we look at a linear equation with just one variable, here one variable x, no y, this is a single variable equation. And we can solve this equation, looks pretty familiar hopefully, and we get a single solution x equals 5. When we start with one variable, all it takes is one equation, and we should be able to solve that equation to find the solution. And then once we hit equations with two variables, not only were the solutions composed of two values, a value for x and a value for y, but also we were able to find an unlimited number of solutions. Now with two variables, once we have two equations, we have a way to find a single solution for this system. And what is at work is that we can somehow join these two equations together to create a new equation that has only one variable. Either it has only left the x or only left in it the y. We'll see exactly how we go about doing that, but understand that our first goal is to create an equation, a combination of the two equations in our system. We combine them to create a new equation that has only one variable, either just the x or just the y. Another idea that I want to remind you of is sort of what is the meaning of an equation, like this one, x equals 5. We're saying that x and 5 have the same value, And we had been using x as representing an unknown number in this equation, and now at this point where we state that x equals 5, it means that any place where there had been an x, it was really a 5 all the time. And we can substitute this 5 in place of the x, and we'll see that it's true. 3 times 5 would be 15, plus 4 would equal 19. So 5 is the solution. It does make this equation true. And now that I've stated here x equals 5, I can do some substituting. Wherever I have the x, I can now put in a 5 if I want to. So let's take these ideas forward. I want to just rewrite these two equations with a little more space on the page. Here are the ideas specific to using substitution to solve a system of linear equations. We first need to find an equation that is solved for x or solved for y, meaning that an x or a y is sitting all alone on one side of the equation, and we've got it down here. It's solved for y equals 3x minus 1. It's necessary that we spot an equation like this in order to do substitution. It is required. It can be an x equal an equation or a y equals equation. In this case, it's the y equals. Now, y equals 3x minus 1. I'm about to use that idea that once we have an equation, it's telling us that the two sides are interchangeable. I just talked about a solution x equals 5, where we could go back throughout the problem, and wherever we saw an x, we could put a 5 in its place. We're using that same idea. Y is the same as 3x minus 1, so I'm going up to this equation here to replace y with 3x minus 1. So we're carefully going to rewrite this equation starting with the 2x, and once we hit y, I'm substituting. Instead of y, I'm putting 3x minus 1 in its place. It's a good habit to always substitute inside parentheses. In this case, it's not going to change anything about how we solve the equation, but I'll always recommend using parentheses when we substitute. So this move right here is the substitution move. We said take the y out, and in its place use 3x minus 1. And the reason we can do it is because we have an equation right here that says y equals 3x minus 1. Wherever you see a y, you know it's the same as 3x minus 1. And that is a helpful strategy because that is how we can create this equation that has only x's in it. The y's have been taken out completely. The equals 9 is coming from this equation right here. All we're doing is keeping this equation the same, just swapping out y, putting this expression in its place. And now we take this new equation that has only x, no y's at all, and we can solve it. And we will have a solution for the x value. Let's make some space over here. I'll just recopy this equation first. I dropped the parentheses. The times that we can just lose the parentheses are when the only thing directly in front is this add sign. So add, or if there's nothing there, if we happen to have a set of parentheses at the beginning of an equation, we can usually drop those there also. So seeing no number, no coefficient, no minus sign, we drop those parentheses, looking at 2x plus 3x minus 1 equals 9. And we're solving this equation, something that should be something we've done for a while at this point. We're looking for like terms. 2x plus 3x is 5x. I'll recopy the minus 1 and the equals 9. I'll show a couple of my steps for solving this equation. I won't always, but to finish solving for x, I'm getting rid of a minus 1 with plus 1 both sides. We're going to be able to bring down the 5x and no constant here left on the left side, but on the right side 9 plus 1 equals 10, so we're making progress to solve for x. One last move, since we have 5 times x, we'll need to divide both sides by 5, and we get x equals 2. There is the solution for the x value. Are we finished? We're definitely not finished. We're finished with half of our answer because remember, this problem started out as a system of equations with two variables. We talked about our solutions needed to be ordered pairs, a number for x and a number for y. And all we have so far is just the number for x. But we're very close to finishing. We actually, in order to find y, we're going to substitute again, because now that we know x equals 2, it meant that anywhere on this page, anywhere in this problem where we saw an x, it was actually standing for a 2. It is now known to be a 2. The best place to substitute back in is right here where we started with our y equals equation. Y equals 3x minus 1. So if x equals 2, we're going to do y equals 3 times 2 minus 1. So substituting in parentheses the 2, and it's going right in place of that x. Remember, we think of these variables as holding an unknown number, but now that we solve this equation that we've got x equals 2, we're putting a 2 where that x used to be. It used to be something unknown, some unknown number is here, but now we know it's a 2. Okay, and then just order of operations. 3 times 2 is 6, minus 1, 5. So there's our y value. Let's just come up with a, we don't have to come up with it, let's go with a nice concise way of writing the solution. How about an ordered pair? And our x value in the ordered pair is always first, the y value is always second. So there's our solution to 5. One last thing that we definitely should mention is that, like almost all equations, we have the ability to check our answer. It's just take these numbers and put them in place of x and y and make sure it makes both equations true. Here, this equation y equals 3x minus 1. And we pretty much showed it right here, but let's just do a double check. If x equals 2, 3 times 2 would be 6, minus 1 does equal 5, and there's our value for y, 5. Is this a solution to our first equation as well? 2 times x, so that would be 2 times 2. 2 times 2 is 4, and then 4 plus y. And we've said that 5 equals y, so 4 plus 5 does equal 9. If x equals 2 and y equals 5, that's a solution to the top equation. And that's what we were after. What ordered pair will be a solution to both equations? We went through our steps for substitution method, and we came up with this ordered pair. So let's get right to another example. This might even be a good one for you to pause the video and try. But if you're not feeling up to trying this one on your own just yet, you should definitely have pen and paper or pencil nearby and work along with me on this problem. We'll go through it together because there are a few steps to remember everything that's required with this substitution method. So if you want to give it a try, pause the video, and here we're going to go talking right through this problem. The first thing we need to do is identify solved for x or solved for y. And again, it's right here, it's our second equation, and it is solved for y. Here's where we're looking first. Next is, how can we do a substitution? We see from this equation y equals negative 3x plus 5, so this expression is going in place of y in our other equation, in the top equation. We always have to find a way to put the two equations together. So here we're taking the expression that equals y, and we're jamming it in place of y in the other equation. So I'll box these off so I can rewrite my equation as I do the substitution. It's this equation right here. It starts with 8x. We are adding to it this expression. I'll do it in parentheses, negative 3x plus 5. And how does the rest of the equation end? Equals negative 5. There is our new equation post-substitution, after we did the substitution. So let's solve this equation. In front of the parentheses, we have just this addition, so we'll lose the parentheses. We have to look for like terms. 8x minus 3x equals 5x. Let's bring down plus 5 equals negative 5. We're just going to keep going solving this equation. I'll take away 5 both sides, or sometimes you could think of it like move the positive 5 over to the other side of the equation and flip its sign, make it a negative 5. Those are two common ways. Let's finish up, divide both sides by 5. It's going to eliminate the 5 right there. We're dividing out the 5. And on the right side, we're left with negative 2. It's tempting to stop right here, but always remember we need to go for an ordered pair solution. And I also think about these problems come full circle. We had to start this problem by identifying the equation that was solved for y, and that's where we end up with this problem. We go back to that equation to substitute in our value of x. It is negative 2, so I'll rewrite the equation, and in place of the x, we are putting in negative 2. And now order of operations. Negative 3 times negative 2, positive 6, and then we'll add in the 5 and see that y equals 11. So we have our solution. It's the ordered pair negative 2, 11. And keep in mind this ordered pair is just basically an abbreviation for x equals negative 2 and y equals 11. So we've seen the basic moves behind the substitution method, but the problems, of course, can become a little bit more challenging than what we've seen so far. So let's take it up a little bit and see some different types of equations that we'll have to deal with. Here's our next system of linear equations. X plus y equals 0 and x equals 3y plus 8. Now this top equation, it might seem odd that we have it equaling 0, but the best way to handle equations that equal 0 is really just to treat 0 like it's any other number. Do exactly the same steps you would do if this 0 was, say, a 10 or a 2 or any other number. So we're not doing anything special because this equation equals 0. Maybe you're spotting, well, if we have two numbers that equal 0, they have to be opposites. I know that it's going to be like a 3 and a negative 3 or a 4 and a negative 4. We don't know exactly which pair, but the numbers will be opposites. Maybe that's something you could spot from this equation. Two numbers added together equals 0, but that's just a little icing on the cake. It's not an important part for our substitution method. Let's just get back to our main steps. So let's get into it. We're looking for an equation solved for x or y, and in this problem it's an equation solved for x. So we had a couple solved for y. Now we're doing it with an equation solved for x. Down here, x equals 3y plus 8. So we're thinking, can we put a 3y plus 8 in place of x in this other equation? That's exactly what we're going to do. So let's clear some space. We'll put the 3y plus 8 right in place of that x. We're combining these two equations. So starting with the rewrite, in this case, our substituting is the first term. It's actually the first part of this equation. So 3y plus 8, it's a habit, so I still have it in parentheses. How does the rest of the equation go? It goes plus y equals 0. So it's looking a little bit different because at this point we had been dealing with equations that had only x, but now it's an equation that has only y. But no big deal. All we really care about is that the equation has only one kind of variable in it. The fact that this time it's a y really doesn't matter. We'll be careful about specific details as we move along, but it's not changing our process. We're going right ahead and solving this equation, losing the parentheses because they're the first term in this equation, and now we're looking for like terms. We have a 3y and a 1y to make 4y. I'll recopy plus 8 equals 0. Again, don't do anything hasty because this one equals 0. Just proceed as usual. Solve for y. So I'm taking away 8 both sides. It's leaving us with 4y equals negative 8. And now divide both sides by 4. We get y equals negative 2. So the first part of our solution this time was the y value, but both are still needed. So now how do we find the x value? It's really the same process. Let's go back to where we started, this equation that was solved for x, because now we have a value that we can substitute in place of y. X equals 3 times y is now 3 times negative 2. Don't forget the plus 8. So we've substituted negative 2 in place of y. We'll do the order of operations. The multiply gives negative 6. And then adding 8, we get x equals 2. So we've got the x, we've got the y. Let's write the ordered pair. Just always cautious that we're putting the x value first and the y value second. And there's our ordered pair solution. Not too bad. So I've got an example coming up here for you to try. Definitely pause the video and take a few minutes to go through this example. And once you're ready, restart the video and we will go through the steps to solve it. To solve this system of linear equations, first is identifying an equation that is solved for x or solved for y. In this case, it's up top, our first equation. We spot that x equals y minus 12. So a y minus 12 is being substituted into the second equation in place of x. Here we go. The equation starts with x, so we now have to start with the expression y minus 12, and then the equation continues with plus y equals 0. There's our new equation once we've put y minus 12 in place of x. Now let's solve the equation. Again, we can drop those parentheses. We're looking at y minus 12 plus y equals 0. Just go carefully through solving this equation. These problems now have lots of steps, so lots of opportunities to go off path. Just be careful with each move that you do. We're looking for like terms. A 1y plus 1y equals 2y, bringing down minus 12 equals 0. Let's take the minus 12, put it to the other side where it's positive. We now have 2y equals 12. And if your preference is to always say, at this point I'm adding 12 to both sides, we should get to the same result. I might not show those steps every single time, but make sure that we're staying on the same page here. So I'm not showing plus 12 on both sides. I'm not even really showing I'm moving that negative 12 over. I'm just telling you that this is what should happen next as we're solving for y. We see 2y equals 12. My next move is divide both sides by 2. Hopefully you got y equals 6. Once we have the value for y, we're going up to our equation that we started with, that x equals y minus 12. But now we're putting in place of y our solution here, 6. So x equals 6 minus 12. Real quick one, just the subtraction equals negative 6, and we have our ordered pair solution. X equals negative 6, y equals positive 6. Let's continue to go through examples as we see some problems that have a little higher level of difficulty to them, but nothing crazy. Our main steps are going to stay the same. We're going to start by identifying an equation solved for y. We have it down here. We're spotting y equals 2x plus 1, and we're putting this expression 2x plus 1 in place of y in this equation. Remember, we always have to look at how it's solved. If it's solved for y, we're putting it in place of y. When it was solved for x, we were substituting in place of x. But you'll always know that you're on the right path when we rewrite this equation. Our new equation should contain either only x or only y. If you're solved for y, you get only x left in the equation. So we'll see that right here. Now, let's be cautious about what we see as we rewrite this equation. Starting off with 2x, we're adding to it 3 times y. Here's where it's key that my substitution is inside parentheses. The 2x plus 1 is going only in place of y. This term was actually 3y, 3 times y. So after our substitution, we need to see 3 times this expression, 2x plus 1, and it must be in parentheses because a distribute will be necessary. That is a good place to go off path, so please be cautious there. Avoid making a mistake, and be careful. When we see this, I know, well, I'll be distributing once I rewrite this equation. I'm putting 2x plus 1 only in place of y. This times 3 is basically sitting there waiting to be multiplied to whatever I just put in place of y. And then the rest of the equation is the equals 19. So here's our new equation after the substitution. And that's the new element that I wanted to show with this example. Just what do we do if we're substituting where our variable has a coefficient? You really don't have to do much different as long as you're in the habit of substituting in parentheses. And we understand that this coefficient 3 will need to be distributed. We will multiply that coefficient 3 to both terms, the 2x and the 1. So how does our equation look now? I'll bring down the first term, 2x. As we distribute the 3 times 2x equals 6x, and 3 times 1 equals 3, equals 19, bringing down the right side. So we're solving this equation as usual. We spot like terms. 2x plus 6x equals 8x. Recopying plus 3 equals 19. Going to get rid of the plus 3. Both sides leaves us with 8x equals 16. I subtracted 3 from both sides. Now I'm doing divide by 8 both sides to get x equals 2. First part of our ordered pair solution. We'll get the second part of our ordered pair solution by substituting that 2 right in place of that x. So y equals 2 times 2 plus 1. That's 4 plus 1 equals 5. We've got our ordered pair solution, 2, 5. So how about one for you to try that will be similar to this? You'll be substituting where we see a coefficient, and you'll need to be cautious about doing your distributive property correctly. Here's the example for you to try, so pause the video, try it out, and then restart the video. We'll go through the steps together. So identifying the equation solved for x down here, the expression y minus 3 will be substituted in place of x. It will be substituted right in place of that x right there. So I'm blocking it off to get some clean space here to work with, and carefully recopy this equation and do the substitute. Instead of 5 times x, we are doing 5 times this expression, y minus 3. There it is in parentheses. We know that 5 will be distributed. How does the rest of the equation finish? Minus 3y equals 1. So we're ready to do the distribute. 5 times y is 5y. 5 times this negative 3 is negative 15. Recopy minus 3y equals 1. We've got some like terms to combine. Be cautious with your signs. We need to see a positive 5y minus 3y, or see that as a negative 3y. However you see it, we need to combine them to equal a positive 2y. And I recopied minus 15 equals 1. Just our usual steps for solving an equation with one variable. I'll add 15 to both sides to get 2y equals 16, and then divide both sides by 2. Y equals 8. Let's wrap it up by finding the x value headed right back here to where we had x equals y minus 3. But since we know y equals 8, we can say that x equals 8 minus 3. And the 8 minus 3 is 5. We got the x, we got the y. There's our ordered pair solution, 5, 8. Let's address this idea a little bit further, because we have to be particularly cautious when we have negative coefficients, which we have in this example. You can feel free to pause the video and try this one on your own, or work along with me right now. So let's identify the equation solved for. In this case, it's solved for y down here. The expression 7x plus 6 will go in place of y right there. And now let's rewrite the equation. It starts with x. Now we have minus 5y, but we will have now minus 5 out in front of parentheses with our expression 7x plus 6 in it. That's going in place of y inside the parentheses. And the equation continues with equals 2. Now be very cautious about our distributing here. Basically what I'm spotting is this negative 5. And when I distribute, I will be multiplying a negative number, a negative 5, to each of these terms. I think that is my preferred way to keep my signs accurate when I'm distributing. If I see a minus right here, I will just go ahead and distribute, multiply through a negative 5. So we start with an x, I'll bring it down. Negative 5 times 7x is negative 35x. Negative 5 times 6 is negative 30. And then the right side equals 2. Now we're looking for like terms. We have, here's a 1x minus 35x equals negative 34x. Recopying minus 30 equals 2. Add 30 both sides, we get negative 34x equals 32. And divide both sides by the negative 34, and we get this fraction, which we can simplify. The 32 divided by negative 34. We can simplify if we divide numerator and denominator both by 2. We get this negative 16/17. Okay, first fraction that we've seen in a solution today, but no big deal. It definitely can happen. There's nothing about systems of equations that says that our solutions need to always be made up of whole numbers or integers or anything. Fractions can happen. What I always recommend is when we get to numbers that don't divide evenly, that you do keep it as a simplified fraction. Avoid writing this as decimal. Keep it as a fraction. So I like x equals negative 16/17. It's not going to be as painless when we wrap it up and get our solution for y, but the steps are the same. We're going to take negative 16/17 and put it in place of this x. So y equals 7 times negative 16/17 plus 6. We'll do some order of operations here. Y equals, now this multiplication, remember, an integer or a number that's not in a fraction, if we multiply it to a fraction, we multiply it just right into the numerator. So to get this result, I did 7 times 16. I got negative 112 over 17. Now I'm going to have to add this to a 6, But if I'm adding numbers, I need a common denominator if I'm seeing some fractions. So the 6, I'm actually going to multiply it by 17 over 17. Negative 112 plus 102, negative 10 over 17. So there's our y value. Let's write our ordered pair here. Negative 16 seventeenths and negative 10 seventeenths. There's our value for x and y. They are the solutions to this system of equations. So the point of this example, we had a couple of them. First of all was be cautious where we have a negative coefficient, because when we distribute, we have to make sure we're multiplying through a negative number. In this case, it was this negative 5. The other point was that we can get solutions that have fractions. When you do see some fractions, it's sometimes tempting to think that maybe you've gone off path. I wouldn't scratch everything and start all over, but maybe once I got to the end, I would do a quick check. And if I put in place of x a negative 10 seventeenths, and I put in place of y a negative 6 seventeenths, it actually does make both equations true. So they are solutions. I can plug them in and check. They work. So there's the wrap to that problem. So now I want to give you another problem to try. Pause the video and try this one. No big changes, just our same basic substitution steps. Be cautious about some of these details we've pointed out about having a negative coefficient where we have to distribute. But go ahead and try this one. Pause the video and work through it. Then restart the video and we'll go through the steps of the answer. Solving this system, we first identify the equation that's solved for y. Y equals 2x minus 5. We're placing this expression, substituting it in place of y right here. 2x minus 5 going in place of that y. So let's carefully rewrite the equation. It starts with x minus y. Now, I'd always substitute in parentheses. So here it is, 2x minus 5 inside parentheses. And it's key that we see a negative right here. Let's just finish this equation, equals negative 6. Now, when we see the negative in front of the parentheses, that is something that has to be thought of as part of a distributive process also. You either think, well, I'm multiplying through a negative 1, or another way to look at it is that when we see a negative sign in front of a set of parentheses, it changes the sign of every single term inside. So this equation becomes, well, first of all, the leading x stays as is. There's no reason to change that. The negative, here I'm showing with arrows where it's going. So x I'm recopying. Negative applied to the 2x makes it now not a positive 2x but a negative 2x. And then the negative applied to this negative 5 is changing it into a positive 5. This is a very common place to go off path, to not be careful about this minus that is in front of parentheses. It needs to activate everything, every term inside the parentheses. It changes a 2x from positive to negative. It changes this negative 5 into a positive 5. That's how to handle that negative in front of the parentheses. The rest of the equation equals negative 6. Let's solve it being cautious. We have like terms. A 1x minus 2x leaves us with a negative 1x. If you just have negative x, that's perfect. Recopied the plus 5 equals negative 6. Now let's get our constants over here to the right side. I'm taking away 5 and showing it to you this time. So negative 1x equals negative 11. And dividing both sides by negative 1, we see x equals positive 11. Or you could say, well, if negative x equals negative 11, then you flip both sides. It means positive x has to equal positive 11. That's a fair way to handle things. Just be cautious with that move. Everything is truly backed up with our steps, our properties that I can divide or multiply the same thing to both sides. I'm not just flipping things when I feel like it, but maybe you observe, well, if negative x equals negative 11, therefore positive x has to equal positive 11. That's true. And let's continue and find our value for y. Let's go up here. Y equals 2x minus 5. So this is 2 times 11 minus 5. Order of operations, we're doing 22 minus 5. Y equals 17. So we can maybe get some numbers that aren't close to 0. They're both numbers bigger than 10, but again, fair game. Fractions can happen. Big numbers can happen. So we've got them. We can always check x minus y, 11 minus 17, that does equal negative 6. and 2 times 11 minus 5 does equal 17. They check out. They have to be correct. So if you're ever not sure about your solutions, just do a check, and then you'll know for certain. And in this case, our solution, 11, 17. Here's another good example for you to try. So pause the video, try this one out, and then restart. And we are going through the answer right now. Y equals 2x minus 7. So I've identified the equation solved for y. I'll be substituting the expression 2x minus 7 in place of this y in the other equation. And now I'm recopying this equation that I just substituted into. 3x, now we have minus 3 times y, so minus 3 times the expression 2x minus 7 equals 1. Now careful with the distribute, it's another negative coefficient, so we'll need to multiply through a negative 3. We're starting the equation with 3x, then negative 3 times 2x equals negative 6x, and negative 3 times negative 7 equals positive 21, equals 1. Now we've got some like terms. 3x minus 6x equals negative 3x, bringing down plus 21 equals 1. Now we'll subtract 21 from both sides to get negative 3x equals negative 20. And lastly, divide both sides by negative 3. Now we cannot simplify further a 20 over 3, but since numerator and denominator are both negative, we should be writing this now as a positive number. A negative divided by negative equals a positive, but the 20 over 3 cannot be simplified further. So now let's substitute 20 over 3 in place of this x all the way back here. Y equals 2 times 20 over 3 minus 7. We've got order of operations. The multiply first. 2 times 20 will make 40 over 3. Now, minus 7. To get this 7 into an equivalent fraction with a denominator of 3, I'm just going to multiply by 3 over 3 to see negative 21 over 3. That's a fraction that equals 7. And it's got the common denominator, so let's do the subtract. And we see 19 over 3, or 19 thirds. So again, a couple of fractions, but they do check out. And there's our ordered pair solution. Keep in mind that we've got the x value first, the y value second, and our solution, 20 thirds and 19 thirds. I'd like to show you just a couple more examples of some situations that look a little bit different than what we've seen so far that you just might encounter. But our basic steps are the same. What we've been doing so far is what we will continue to do. Let's start the problem by identifying the equation that is solved for x or y, and it's our top one. It's solved for y. The y is isolated here on the right side, but totally solved for y. That's fine. It doesn't always need to be on the left side. This looks just fine the way it is. And thinking about how we will substitute, we will take this expression, 10 minus 13x, and we will be substituting it where? In place of y, right there. So let's recopy this equation that we're plugging into. 4 times y is now 4 times this expression, 10 minus 13x. And the equation continues with plus x equals negative 11. Now, solving this equation, we need to do the distribute first. 4 times 10 and 4 times negative 13x takes us to 40 minus 52x, and then plus x equals negative 11. We have like terms right here. A negative 52x with positive 1x leaves us with a negative 51x. I'll bring down the 40 and bring down the equals negative 11. I'm going to continue working. I'll now get the constants over to the right side, so I'm taking away 40 both sides, and it brings us to negative 51x equals negative 51. Interesting, but when we divide both sides by negative 51, we see that x equals a nice positive 1. Now let's find what our y value is. Let's take x equals 1, and we'll be plugging it in right up here. 10 minus 13x equals y, so 10 minus 13 times 1 equals y. And our order of operations will take us to 10 minus 13 equals y, and that's negative 3 equals y. And if you ever felt a preference of always seeing the variable on the left side, you're free to flip-flop sides of an equation. You definitely could have said, I'll just feel better going through this problem if it looks like y equals 10 minus 13x. Totally fine to do that. We should come up with the same answer either way, that x equals 1 and y equals negative 3. So a slightly different appearance to these equations, but we still saw the key components: an equation solved for y and a place to substitute it into the other equation. Here's another interesting example that you might see. Y equals 3x minus 2 and y equals 5x plus 6. So the question is, which of these equations do we use to start with? It really doesn't matter which one we pick. They'll take us to the same road either way. So I could say, here is an equation solved for y. I'm going to take 3x minus 2 and put it in place of this y right here. That's going to give us the equation 3x minus 2 equals 5x plus 6. But what if you saw it the other way around? What if you spotted the second equation and said, here's a 5x plus 6 that I'll put in place of the y right there? It's getting us to the same equation. We see that the sides have been flip-flopped, but they're both stating that 5x plus 6 and 3x minus 2 are equal. And even a third way you could think about a problem like this is, well, if 3x minus 2 equals y and 5x plus 6 equals y, if they both equal y, then they have to equal each other. It's like if you share the same birthday as Tom and I have the same birthday as Tom, we must have the same birthday. Same idea. So two things equal y, they got to equal each other. So however way you look at it, any way you slice it, we're getting to an equation like this one right here. And now let's work to solve the equation. I'm working to get the x on the left side and constant to the other side, the right side. So I will take away 3x from both sides. And at the same time, I'm going to take away 6 from both sides. I'm getting the term with the variable off the right side and the constant off of the left side, both at the same time. Feel free to try it at home. So the 6 wipes out the negative 6, 3x minus 3x. Carefully, what are we left with? 2x equals negative 8. And if you did that process in a couple of steps instead of just one big step, we should be getting to the same spot. 2x equals negative 8. So we're going to finish solving for x, divide both sides by 2, x equals negative 4. Now let's find our y value. Take negative 4 and substitute it in place of, well, here's the question. Where do we go? And again, it doesn't matter. Do I substitute negative 4 in place of this x or in place of this x? It doesn't matter. It's going to give us the same answer both ways. That's how this whole system works. But I'll show it to you anyways. So if we took the top equation, y equals 3x minus 2, plugging in the negative 4, we would have 3 times negative 4 minus 2. Order of operations gets us to negative 12 minus 2, then negative 14. Y equals negative 14. And if I chose the second equation to substitute into 5x plus 6, 5 times negative 4 plus 6 gets us to negative 20 plus 6, and then negative 14. Same result both ways. So it doesn't matter how we spot the substitution initially. Maybe what I'd prefer is to say if they both equal y, then just set them equal to each other. And it doesn't matter which one we choose to substitute back into. It's actually even a good way to check that we did the first part correctly, that it does have to give us the same thing in both equations. If it didn't match, it means that we found a wrong answer initially. So there's the rundown with a type of system you see where they're both solved for y or both solved for x. No huge difference. And now one last example where we don't have either equation solved for x or solved for y. I said at the beginning of this video that it is required for substitution method that we see an equation that is solved for x or solved for y. And if we don't have one, there are a couple of options. One is that we choose an equation and we solve for x or solve for y, then proceed as usual. Or we use an alternate method. We don't do substitution method at all. We do the addition or elimination method. So if I see a problem like this, personally, I would probably choose to do the addition or elimination method. But just to still stick on our substitution method and to tell you how you would approach a problem like this. We'll go ahead and solve for y or x. We'll talk about choosing that, and then we'll finish up with substitution. So, any thoughts about which of these equations we should pick to work with, and if we should be working to solve for x or to solve for y? And this guy is pointing really at the biggest clue already. We should spot some variable that doesn't have a coefficient currently. Any of those will be the easiest to try to isolate in an equation, to try to solve for. So this y right here is telling me choose this equation and solve for y. It's going to be easier than trying to isolate that x because it has a coefficient of 3, that x has a coefficient of 2, this y has a coefficient of negative 3. So here's the one saying solve for me, solve for me. So let's take that equation. 3x plus y equals 7. Just bring it over here. I'm recopying to give myself some space for this process. Solving for y means clear any other terms from that side of the equation. So the 3x has to go. I'll take away 3x from both sides. That's leaving the y isolated on the left side. On the right side, we have two terms that are not like terms. So please refrain from thinking I can do 7 minus 3 and have 4 of something down here. Absolutely not. We cannot do that because this is a term that has a variable. It's negative 3x. It cannot be combined with a number by itself. So if you're used to, if you just came from doing a lot of graphing and you've done a lot of solving for y, you might still be in the habit of putting your x term first and the constant last, thinking I want to get it in a y equals mx plus b form. And if that's your thinking, you should see y equals negative 3x plus 7, because that's a positive 7. The other way to see it would be, oh, I see 7 minus 3x. I know they're not like terms, so I'll just call it 7 minus 3x. That's a-okay also. Both ways are just fine. We're not graphing, so I'm not compelled to try to put that x term first. Either way, we're good to go because we have the same components. They both are a positive 7 and a negative 3x. So either order is going to be just fine. So now let's recollect ourselves and see we do have an equation that is solved for y, and we'll need to take this expression and substitute it in place of y into our other equation. So we're needing to substitute it into the y right there. And let's make some space and carefully recopy 2x minus 3 times, in place of y, I'll go ahead and use the 7 minus 3x, equals 4. Now we have a careful distribute because we have a negative 3 coefficient. So 2x minus 21, and then the negative 3 times negative 3x will make a positive 9x equals 4. Careful with the distribute there. Now, like terms, 2x plus 9x equals 11x. Bring down minus 21 equals 4. And we're just going to wrap this one up, add 21 to both sides. 11x equals 25. Then divide both sides by 11. Won't divide evenly, so I've got this improper fraction. It's simplified 25 over 11, and it's looking exactly the way I want it to look. A simplified improper fraction. Now let's wrap up getting the y value. We need to put 25 over 11 in place of this x right here. So y equals 7 minus 3 times x, 25 over 11. Careful order of operations, so let's do the multiply. Negative 3 times the 25 in the numerator. That takes us to y equals 7 minus 75 over 11. To get a common denominator, I'm multiplying 7 by 11 over 11 equals 77 over 11. And now we can do a subtract to equal, it should be a positive right there, 2 11s. So I'm going to put that guy, hide the negative sign, and that's a positive 2 11s. So we have our value for x, and we have our value for y. So that's a good place to end our discussion about solving by substitution. We've seen a lot of the ins and outs about how to handle these problems. Next up for us will be the addition or elimination method.